Yay. Hi. I thought I might as well stream because I decided to make. Wow. This is. Let me fix the lighting a bit first. 2 seconds. Am I less overexposed now? Not really. Okay, who cares? And Windows probably reset my speaker. Not volume mixer, please. Sound setting. Here. Full panel. Okay, but the mic. Levels. Hey, okay, it is correct. Felt like I was hearing myself very low. 1, 2. Yeah, we'll just have to. Just have to survive with that. I was going to model myself something probably horrible because I need a stand in my shower for my phone. Everybody needs that. So I thought I'd model something to hang, basically to hang the phone on the aluminium rod which the shower head hangs on, because the shower head doesn't hang straight on the wall, it hangs on an aluminium rod. And if I could clip a holder on there where I could put my iPhone, this is an XS, but I think my girlfriend's iPhone, what is it, 8? Anyway, I think that is pretty similar in dimensions, so that should work too. Or we could make some wiggle room, and I'll print it out of PETG, so it should probably be okay anyway. If I could print something to easily hang it there, that should yeah, I might as well model it here, and you guys can listen to some piano with me and come with some suggestions if you have any. If there's anybody that wants to suggest something, I'm totally okay with that. So how I thought I was going to start with this is just, I have my measuring stick here. If this is the bar, I think we should just have a stand like down here, and these two is connected to it, so we can turn it like that and just lock it. So it shouldn't go up or down at all, it should be able to just lock. Or it won't lock, if you pull it, it'll slide, but the phone isn't very heavy, so it shouldn't slide a lot, and there's a bit of grip in PETG, so maybe it'll work. First, I thought about making some intricate kind of slices on top of each other that would kind of dig into, it won't dig into the aluminium, but it will kind of be stronger the more you pull on it. Although I think that'll be unnecessarily intricate. So either I'd like to start with some kind of some half moons or something like that, crescents that go against each other, or just bars, basically bars on top of each other. I think I'll first try to model. First of all, I know that I've noted down that the aluminium rod is 18 millimeters thick. And what are the dimensions of an iPhone? How thick is an iPhone XS? iPhone XS specs. Well, I don't really care about the resolution, I care about the physical specs. Marina, here we go. So the iPhone is 14 by, no, 140, that I don't care about that. 7.7 millimeters thick, so about 8 millimeters thickness. There we go, there's makers and crafting. There. About, yeah, 8 millimeters thickness. Let's add some parameters. iPhone thickness. Let's say 8 millimeters because my iPhone also has like a thin gold. It's a plastic cover basically, and just maybe, I'm not sure you'll be able to see it in the, no, anyway, you can see it's matte, so it does have a tiny quarter of a millimeter thick maximum sticker basically on it, which helps. I like it, but let's say 8 millimeters and add some tolerance, 9, because I'll make a clamp for it. So let's say 9 millimeters. And to 3D print this, the ideal way of making it would be for it to basically just be one profile that you can print out. Would that be possible? No, it wouldn't be possible for it to be just one profile, but I should be able to almost just print one row up basically. Let's see. Yeah, the iPhone thickness is 9 millimeter. We're saying it's not properly 9 millimeters, but we can make the hole for the iPhone to be 9 millimeters thick, the bottom of the hole at least. And then the rod okay, alu rod, let's say that thickness is 18 millimeters. I think that'll do for now. Yeah, that'll do for now. And then let's start with the bottom of the tray basically. Create a profile for that. Should probably have a tray plastic thickness to tray. Yeah, okay, so thickness is basically the wrong word. It's the depth for the iPhone. Let's change the names there. How thick PETG will we need? Maybe a millimeter? 1.5 should be more than enough. 1.5 millimeters. 0.5. It's the depth. iPhone depth. It's a better word. And the alu rods diameter. So that so the thickness of the walls, tray wall. There we go. Tray wall thickness, and we'll need some angles too here. Okay, cancel that. Tray angle. I'm not sure we need a tray to be at an angle to the rods, really. The rod is of course totally vertical. Yeah, Oh, let's see. Let's have a look later. Right now we'll put it at like 2 degrees or something. So we have a tiny angle between the rods and the tray. So the phone leans a tiny bit back. Here we'll have tray wall thickness. That'll be the floor basically, so. And that'll be the bottom of the tray. No. iPhone depth. Here we go. That's the wall thickness, and we'll need to add another wall thickness here. Yeah, we can just add plus 2 times the tray wall thickness. It's a bit loud for me. There we have it, and we can place the walls on top of here. And I want the front wall, because I intend this to be the front. Is it in the... No, it's the right, but who cares? I want that to lean in a bit. So if we do... put the lip height there. Let's make a lip height. Tray lip height. 5 millimeters? Oh, a bit more than that. A centimeter maybe. Yeah, because the iPhone is rounded, so I think 5 millimeters will not really help anything. So let's try a centimeter. 10 millimeters. So something like tray lip height. I always press tab instead of enter. Yeah, that should be okay. And then we should be able to put an angle between those two. Oh, how the hell? Yeah, let's change that and just force it. A 3-point rectangle. That should be the tray wall thickness, and then set the second point like there. Should be the tray lip height. Then we can set the angle between those two to be like 4 degrees or something. Yeah, tiny indentation in the lip there, so this can help hold the phone. I'll make another parameter. Back height. That won't need to be huge either, but probably a few centimeters, right? Like 4 centimeters? How far up on an iPhone is 4 centimeters? Let's see. So that's 4 centimeters. Like that. That's a bit, it should be enough to hold it at least, or to have something to lean against. And like very upright, that won't help. It'll actually help less the more upright it is. So let's give it 4 centimeters. Start with 4 centimeters and see what it looks like. Then, yeah, because that, no, not line. Let's give it a rectangle. Tray. Back height. That should be the tray thickness. So the iPhone can stand down this when we pull out this towards me, towards the screen. The iPhone should be able to fit in here. Let's inspect how far it is from that corner to that wall. 8.3. We need it to be less. Yeah, we need less. So let's make the angle here a bit more of an angle here. We put 8. How far it is 7.6. Should be enough. It won't put a lot of, yeah, it won't put a lot of kind of pressure on the front of the iPhone, and we will curve this a bit. So I think I want it to be even more of an angle here. 12 maybe. Something like that maybe. Let's hope that'll work. Because we'll also make another 3-point rectangle. It'll be the thick. No. That I'm not that concerned about the height of this. 5 millimeters. 4 millimeters. And then we'll have to paint the angle between those. That should be more, 30 maybe. Because then it should be more than enough space here for the iPhone to fit in there, so I can just push it down. This will open a bit. And more, maybe 35. Yeah, that looks good. 23. Yeah, that shouldn't be too sharp. Yeah. Well, let's leave it like that. And that's the tray, basically. The basic shape of the tray. I'm a bit scared that the back will not be strong enough with just 1.5 millimeters. It's not a lot. It's not a lot of plastic. Might be. Oh, that's very little. That's not a lot. Especially to hold my dad down. What is it? $1,300 phone? No, $100? $1,000. I'm sorry. I skipped the 0. So $1,000 or $1,300 phone. It's let's increase this thing. 2.5. There we go. Hey, you're supposed to be restricted to the same. Supposed to be thick. There we go. That might be safer. And we'll fix the edges a bit later. Now, is it still wide enough there? Yeah, that's just about 7 millimeters. I think that'll be good. And this might actually work. Just 2.5 millimeters now. Right, 2.5 millimeters thick. That should be enough. Let's start with that. It will also be really quick to print. So that's. And how wide should it be? Keep the iPhone pretty stable. It needs to be basically almost as wide as this iPhone standing up. With the iPhone lying down, it doesn't need to be wider than the iPhone standing up, but just about there. see how wide is an iPhone without the kind of curved parts at the end. It's like 6.5 centimeters, so make it 7. Let's extrude that 7. Extrude all of these things 7 centimeters. No, we will add a parameter for that. Tray width 70 millimeters. And tab. There we go. Why won't you do that? No, not tapering. Did it actually? What? What? Wait. There we go. Then we have the super basic shape of the tray. So this needs then to be... We'll smooth it out later. I don't care for that right now. Smooth that out later. Also, we should probably... I regret making this an angle now. We should probably just define how wide it should be there. Let's see if we can do that. If we just delete that, then try to restrict that. Will it be angry at us? No. 7. Have that be 7 millimeters, because then if we increase the height of the lip here, we change the height here, it shouldn't be a problem. Be okay. Yeah, it shouldn't. Basically, it shouldn't fail if we increase the if we increase the height here. It doesn't go further in. It just slightly straightens up. So that should be good. Okay, there we go. And then what's worse is the grip. How do we grab hold of? How do we grab a hold of the rod, of the bar? I think basically the easiest way is just to make just a rod out from the back of the tray. The simplest solution is to make just two. Let's see if I can sketch it really quick. The really simplest solution is just to make two kind of 5mm circular rods where like that or something, where the distance, let's see, the distance there needs to be that plus 5 at least. No, not that, plus 4 then. You have a little wiggle room. Then the distance from there to there needs to be a bit bigger. Let's just something like that. So, because now the distance between those two there is more than big enough to get the rod in there. If we pull both these, if we hook these up to the tray and just pull these two out, straight out of the screen, there's enough space in between there to get the rods, the aluminium rod just through here. And then if we turn it, should the aluminium rod should lean against there. So the circular aluminium rod should lean something like that against the two circular parts. And it should hold it in place. Just that should hold it in place. I think. I'm not sure, but I believe it should. So I don't think we need to, at least when this, yeah, because during printing, the PETG is a bit sticky. It's strong and it's a bit sticky. So during printing, it will also get a bit of, because I'll print it with my, what is it, 0.8 millimeter nozzle. So it will be, it will have some structure on it. So it will grip the bar a bit. Let's try that. I think 5 millimeters is a bit small. Yeah, I'd like a centimeter basically. Let's call them grip rods. Grip rods. Diameter. Diam. 10 millimeters. Okay, so then if we delete you. Bye. Delete all of them. Because then this sketch now is on the back end there. We could, and also we could later just print a quick one of these in red PETG, which is what I have in the machine right now, in the printer right now. Could just print that in red PETG and see how it goes. So yeah, it'll take minutes. We'll slice it later, see how it goes. Yeah, so as long as the first bar might as well, the first grip bar might as well be all totally kind of on the top of this, because the tray might as well lay straight all the way into, well, not totally. Let's pull it away a bit to have some wiggle room in case it droops a little. And I would like it to, yeah, just to kind of have some clearing, so it can droop a bit and we can fix it without being totally, without it being useless basically. But if we hook it there, whoa. Let's start a new sketch just to sure we're clean here. So if we make a circle and hook it in there and define diameter, there should be, well, diameter should be, it should be 10 millimeters, but it should be the, what was it called? Grip. Ah, might be too much. It should be the grip rod diameter, but we should lower it a bit because I'm not sure it's a centimeter of, it's a centimeter clear of the wall there. Let's make it 7 millimeters then. What is it? Grip rod. Something like that. I'm pretty sure that should be okay. And yeah, that should be okay. We should also, that might also be just about the same. That should work fine. And then the distance from that, from the edge of that to the next one, from the edge of that to the edge of that needs to be less than the diameter of the rod we're hooking it onto. So like by maybe a couple of millimeters, maybe that's a lot. 1 millimeter, something like that. A couple. Let's make it. My measurements might be a bit off too, so let's make it a couple of millimeters. The arm here also, the distance here basically will also change how strong the force that is pushing down on the, what is 70 millimeters here? How strong the force in the angular momentum, how strong the angular momentum round here is basically, so and how well hard this is pushing into the rod. So it's a bit dependent. That thing. We could pull that out a bit because that will make the probability that it hangs there a bit higher. Let's make that a centimeter. From there to the center of those two should be the aluminum rod diameter plus the grip rod's diameter minus like 2 millimeters, something like that, because then we have from there to there now is 2 millimeters shorter than the aluminum rod. Also, when I think about it, I should have done these guys later, but I'll show you why. But anyway, then we can extrude these guys. They need to be at least as deep as at least as deep as the aluminium rod is, or technically at least half the depth, but that won't be stable at all. So at least as deep as the aluminium rod. Also, we might as well. I'm going back on that. We might as well just add these things. Let's see. Potential. Let's just add some pretty strong. That from that point down, like something like that. Just a very simple. Those two. There we go. Potential connection. Because we can round out this later. And then, because that's just to hold the two rods there. Let's extrude all these. Use the tray thickness there, can't we? Tray wall thickness. Yeah. And then we need these guys again. Top here. Or we might as well just extrude them again. Will that be okay? Looks like it. Yeah. Let's set the extrusion length. Out of that. These guys. Extrusion length there should be the alu rod diameter. At least. Plus something. Let's add a centimeter. And then we might as well, just to create a test print, we might as well just make the tray the same width. How wide did this become now? 28 millimeters. Almost 3 millimeters. I'm not sure I'd allow my my iPhone to stand on that. Yeah, let's because this is very easy to print. That's the best argument pro doing it like this, because we can just lay it on this like that, and it will slice really nicely. It won't be super strong because the slices here will be that way. So it won't be super strong. These guys won't be extremely strong, which is a bit of a concern, but I don't really care yet. Let's try to print a slimmer. Just let's make the tray width like 30 then. We have something very easily and quickly printed, and let's smooth off some edges. this, and this should probably be like a 2 millimeter delay. This, let's see, millimeters. This is done with no rationale behind it, just by eye. Yeah, that too. Oh, that could be a bit sharper. Shouldn't be just an edge because it'll break easily, but yeah. And the outsides here. Yeah, of course. Not that much. Or maybe 4 millimeter fillet. Millimeter. It's good. Yeah. And get a millimeter up top here too. Good. And all these guys, well, let's first of all, these two, might as well get softening. 4 millimeters is too much. Damn it, don't crash. Yeah, there we go. There we go, something like that, making it a bit easier to center them. And yeah, exactly. Filling out those guys. Bit of a bitch. Yeah. To join this. Yeah, okay, I don't read. That won't be go down well. Let's try. Yeah, good. Here we go. That edge. Same here. Not 23. Go. Should be okay. Net? I think so. Ah, there's an edge. Aren't you guys not new body? Join. There we go. Then that should be okay. Then it should be easier to fillet these guys. Which one is this? Ooh. This guy too. That help round it off. There's some problems with that edge, I believe. Find. Then that whole edge. That whole edge probably. And that edge, this edge, that edge, least. Now it might be okay. No. Where are you having problems now? Yeah. Let's take him one by one. A 1mm is okay. Where is it? Where is it crashing? I don't care. Let's leave it 1mm. It's good. That'll be interesting. Okay. Worked. Okay, good. Then that's the last one, and we have no sharp edges touching our phone or anything. I don't want sharp edges in my shower. Brooklyn Harvey, no, it's okay, but thank you for the suggestions. That should be okay. Let's try to export this and see if Prusa Slicer feels happy about it. Let's save it first. First try. Save STL. Shower, phone, stand. Then in Prusa Slicer, find it. Here we go, and our settings are for our i3 Prusa i3 Mark 3S with see, no, not side, this side, with 0.8mm 0.8mm nozzle on my super silent settings. That's the we are working, so be quiet settings. The super duper silent settings are we are sleeping, so really be quiet settings. So I might as well use these, and not so silent settings. And I have my own high flow P to G settings here because the 0.8mm nozzle can really push out some plastic. Well, like no problem pushing out twice or 3 times as much as the 0.4mm nozzle. There we go. It sliced pretty nicely. It's with 0.65mm layers, so it's really rough, but it works. And basically the infill is only in the rods there. Let's see, it says it takes about 18 minutes. If we 100% fill it, yeah, right. Still takes 18 minutes, so we might as well. It'll be a bit stronger because with this high fill rate, I don't think the gyros are very good. So let's do that. Work my G code, and I'll just straight to my octo print. Live. Yay, good. The Octoprint is live and let's get I should move, if I can move the cam to show the printer while it's printing. Ignore the box of WD-40, it's not used to to lubricate the printer, used to clean. Also used to clean out some gunk in another system, basically in my computer cabinet. Yeah. Come on. Not the STL, I can't. But it starts heating up. Now move my cam so you can see it. Do believe I have a cam stand here even. There we go. It's heating up. It's at like 70 degrees so far. It will be printed in red 3dnet.no PTG. Move this a bit and we can resize the webcam a bit. There we go. Like that. Lock it again. And then I'll let that print and I'll test it and I'll be back. It should only, like it said, it should only take 18 minutes to print. It shouldn't. I believe I've turned off all the all the audio sources here. So that shouldn't.